If you guys had to build a roadmap for people who wanted to get really deep on AI evals, what topics should they learn?
Great question. So Shreya and I have developed this course reader. It's actually a very extensive set of notes. One might even call it a book. It probably will become a book. It's 150 pages. This is the detail that we go through in our course. We arm our students with a lot of information to make sure that they get materials in many different ways, including live instruction, office hours, but also this very detailed sort of treatise on like how you go through eval step-by-step process. So we start off with, like what is evaluation? We go through the 3 gulfs framework that we just described. We talk about why you need evals. We motivate that. Then we kind of do a little bit of overview of like, okay, the strengths and weaknesses of LLMs, what kinds of things you need to intuitively understand when you're doing evals before you even get to evals. The 3rd chapter is very important. It's probably where we spend a lot of our time in practice, and a lot of people, we don't know about this step. It's called error analysis. So what is error analysis? So you might hear Shreya and I talk a lot about looking at your data. We keep beating people over the head with this phrase, look at your data, look at your data. What does that mean? Look at my data. What data do you look at? Do you look at all your data? Do you just quit your job and look at your data and do nothing else because you don't have time? How do you look at your data? And what do you do when you look at that data? Like, how do you make sense of it? How does it make it tractable and learn something from your data? What if you don't have any data? Like, what data am I talking? What if you haven't built anything yet? The key thing is like you need to look at some sort of data, go through a structured process. It's not as painful as it sounds looking at data. It's actually really beneficial. A lot of my clients, we have a plan to go through this whole process, and they get so much value just out of error analysis that they're like, this is amazing, I'm done. I'm like, wait, what do you mean you're done? Like, I can do all this other stuff. But you're like, no, this is great. Like, I'm busy for a while. Error analysis has taught me so much. And, error analysis is, to go to error analysis, we can scroll through, let me see if there's a diagram here. But, this is like one way to generate synthetic queries, for example. It's hard to dive into the details just without the context, but we go through the process of like how to generate, synthetic data, and then also we go through like how to look at your data. So we describe it in a lot of detail. A lot of it is supplemented with videos. Let me see if I can scroll up. Maybe Shreya, you can...
yeah, that diagram is pretty good.
Yeah, this one.
For
so there's a concept called axial coding, or open coding and axial coding. Shreya, you want to tell us, everyone, where that comes from and the history behind it?
Yeah, definitely. So in creating this curriculum, we took a lot of inspiration from social science research, actually. Because we were thinking, okay, in what field and domain do people need to look at vast amount of unstructured free-form text and labels and come up with meaningful, actionable insights out of it? Well, it turns out social science researchers have done this for a very long time. There's this process called grounded theory that gives this systematic structure to the process. And first, what people do is go through their open-ended data outputs or whatever it is. They read them and they write free-form open codes is what they call it. Free-form notes on what's good, what's bad, any themes that emerge, whatnot, on a trace-by-trace basis. Then after going through about 100 of those, they will try to merge similar notes together into clusters. And this determines your failure modes. If you find that a bunch of notes around a specific type of hallucination get merged together, well, looks like that's a huge problem that you need to solve in your product. And this kind of loop keeps going until what we call theoretical saturation in qualitative research, which means I've not learned any new failure modes. That's all. I keep looking at data and I just keep adding to my existing failure modes. At that point, you can kind of stop, and then you can move on to, okay, how am I going to turn those into automated evaluators so I don't have to do it all the time? Maybe I'll build LLM as judges based on my labeled failure modes. Maybe I'll write some code-based evaluators for things that code can check. And then we find that, we teach people this diagram, error analysis, and then suddenly they're like, oh, this is great. Okay, bye. It's like, I mean, I guess, right? Like, it makes sense. This is where most people are actually bottlenecked, right? Because ML, traditional machine learning people, didn't have to do this. They didn't, when they looked at their data, they would just look at all these tables of features, which are all numbers, and the outputs are also numbers. And so there are ways to kind of debug those. LLMs are different because now the inputs are freeform text and the outputs are freeform text, and people are like, I don't know how to. It's new technology. It's new skills that you need to be able to make sense of that. But fortunately, once you do this, then you can go and implement automated evaluators as you might with traditional machine learning, and then you can do improvement strategies. You can do fine tuning, all of these things, like a traditional machine learning person would.
I hope you enjoyed that short clip. You can check out the full episode here.